Same, thanks.
And as I said, the slides are in the content channel. So please feel free to go grab a copy of them. Thank you to our sister companies. Thank you to Herman, who is actually going to start working for Active Countermeasures the beginning of next month. We're super excited about that. Thank you to Fire Serpent. Both of them gave an awful lot of help in getting the content together for these presentations. Here's what you're going to need. We're going to do a little bit with Wireshark, so you're going to want to have that installed. Um, T-Shark installs as part of Wireshark, and depending upon what operating system you're on, it may or may not end up in your path. I tend to find installing Wireshark on Windows doesn't put T-Shark in your path automatically. You got to do it manually. But Linux, Mac, it will actually end up being in your path. Um, Install ngrep. I added an additional lab for that. And there's that the decode one I gave you last week to download. There's a Fiesta C2 one to take a look at as well. So that's the stuff to go through and grab. So when we talk about packet sniffing, what are we talking about? Well, packet sniffing is a little bit of a misnomer because technically we're doing frame sniffing, right? We talked about that. When we talk about a frame, we're actually including the layer 2 information as well. And you do get that when you go through and you grab things off the wire. But someone who was older than me decided to name it packet sniffing. So that's what we just kind of live with to these days. We tend to, a lot of the labs and stuff we do, we tend to read PCAP files, but you can actually monitor stuff live with any of these tools. Um, you can also write with these tools, which is where those PCAPs come from in the first place. So we'll play around with that a little bit. You know, I always kind of get asked, what's the best packet capturing tool? And my answer is always, what are you trying to do? Right? That is, and that's one of the things I kind of hope you pull out of this presentation is that there really isn't one tool that you can say this is the perfect tool all the time. They all kind of have their strengths and weaknesses to them. A lot of us tend to live in Wireshark. A lot of us has used Wireshark, and maybe not a whole lot outside of that. And I will certainly talk a little bit about Wireshark for the folks that have never seen it. But I'm kind of hoping you pull out of this, oh, hey, that's cool. And I'm not even sure how I would do that in Wireshark out of some of the stuff we're going to go through and cover. So Wireshark, yeah. So Wireshark ends up looking a little bit like this. So we've got a summary window up at the bottom, excuse me, up at the top. So that summary is just kind of giving us some minimal generic information about what's going on. The info field tends to be nice because that tends to kind of break down some of the interesting fields that may be part of that packet that's going by. Keep in mind that what we're looking at is every single packet that's part of this session. So it's not like, this is one connection, this is another, this is another. These may all be part of that same connection taking place. So we're getting into a real level of detail with this. I've talked about Zeek in the past, and I talked about what Zeek records is a summary of each session. So really what Zeek is doing is it's taking all these packets that are going back and forth as part of a single session and just summarizing it out for us. So it gives us a little bit less to go through and process. So whether you need to actually get into the raw packets kind of depends on the level of detail that you need to be able to go through and do. So yeah, so like I said, this top pane here, this is going to go through and this is going to give me summary information. So I'm going to be able to go in there and I'm going to be able to see, who's talking to who, what ports, again, kind of generic summary information. The middle is where things start getting kind of interesting. Because in the middle, what we have is an actual breakdown of what's in the headers of that frame that's going by. So I mentioned it's frame capturing, not packet capturing, and here's a good example here. Here's my frame information. Actually, I want to go to this one. This will actually show me what's in the frame itself. The frame information up here is more of a generic information about this particular frame. This is the actual header information here. But I can go through and I can navigate through any of the headers. What's kind of cool is if I click on a field, you'll see in the bottom, it'll light up and it'll show me where that field is and what that value is. So when it says, header checksum unverified, well, because it wasn't verified, it didn't highlight that one. Of course, I had to click on the one it wasn't going to work with. So the source IP address, right? So when it says, hey, the source IP address is this, where did that information come from? It's showing it to you right here. So you can actually go in and convert this stuff yourself to be able to go through and see is it pulling this out correctly and is it not? Uh, I do a pay what you can packet decode class. And one of the things I go through in that is I actually point out some of the places where Wireshark is wrong, meaning that Wireshark either presents information that isn't really there, or it presents information and claims it's part of one header when it's actually part of another. And the way you kind of figure that stuff out is, again, to be able to go through that bottom pane and kind of decode things for yourself. There's a lot of really cool features with Wireshark. You can go through and you can ask it to summarize the data it sees, who's talking to who, how many packets, and that type of thing. Keep in mind that that is statically generated. What I mean by that is, imagine I have a 24-hour PCAP, and at the start of that 24-hour PCAP is a internal system talking to an external system from port 2000 to port 80, just to throw out some port numbers. And then 23 hours and 59 minutes later, that same internal system just happens to select that same source port of 2000 when it goes and it talks to that same web server again. When Wireshark summarizes that connection data, it's going to tell you that those two systems were in communication with each other for a full 24 hours, even though they weren't, even though there's only two sessions we're talking about, and they may have been, 50 milliseconds each, and that's it. Wireshark will incorrectly call it as a 24-hour session because it's saying, well, I saw this source IP import way up here in the packet in the decode, and I saw it way down there, so I'll just add up everything in the middle. What the hell? It's not looking at, well, did the connection close or anything along those lines. So I want to be clear here. Wireshark is an awesome tool. I would say from like a detailed level analysis, it's probably one of the best tools out there, commercial or open source or otherwise. But it's not always perfect. It's written by humans. Sometimes humans make mistakes. So this is why it's still important for you to understand how this stuff works, so you can catch stuff like that when it happens. One of the other really popular features with Wireshark is if I right click on a packet in the session, one of my options down here is to follow that stream of information. And what it will do is it will knit together all of the packets, and it'll create something that kind of looks like this. So what this is showing me is um, anything in red is data that was sent from the client to the server. Anything in blue is data that was sent from the server to the client. So what I can see here is the client sent some information that doesn't translate well into ASCII, but this is inside of it. This is actually what we're looking at is a TLS session. So we're looking at a secure session, TCP 443, from an internal client to a server. And the first thing that happens in a TLS session is the client shares its SSL hello packet. Part of that is the SNI information of what server it is it's actually trying to talk to. Down here is the server responding. What you can see in here is information about the digital certificate and who it was issued to that's coming back. That's part of what happens when the server responds, right? So the client sends its SSL hello packet that says, hey, here's what I want to do to try to protect this data, and here's who I'm looking to talk to. The server will respond and say, here's my digital certificate, so you can prove you're actually talking to the endpoint you think you are. And out of the things that you say you can negotiate, here's what I'm capable of using. And then once we get down into this area here, what we're actually looking at is encrypted traffic. This looks this is a little cleaner and easier to read. If we actually, I'm going to go to that Fiesta C2 capture file that I gave you. And I'm going to go through and I'm going to follow that TCP stream. Oh, that's the other thing you'll run into as well. So notice on this first packet, when I right click on it and say follow, my only option is TCP stream. But if I come down here to where there's HTTP information and say I want to follow it, oh, look, HTTP shows up as an option. Well, this is all part of the same stream. So this is another situation where Wireshark is acting statically versus statefully. Because it didn't see any HTTP header information in the SYN packet, which there shouldn't be any, it didn't list that as an option. It's not like it looks at the whole session to say, oh, what's this protocol? Okay, here are the options associated with this protocol. So it's going to kind of change things as it goes through. Now, with that said, the analysis I'll get by following a TCP stream versus HTTP actually ends up being pretty much the same. So it isn't going to go through and kind of beat you up. But this makes this to me is a little bit more clear, to kind of see what's going back and forth. So in red, this is what the client is sending to the server. So this is a GET request for a file. And it's identifying, the referrer field that sent it to this system, what's the user agent string, all that other fun stuff. And then here's the receiver responding back. Here's the receiver coming back saying, hey, that file you want to access, there's no data. That's the file is there, but it has no data in it. There's no data to return to you. So, and there's some additional header information that shows up as part of this as well. So again, that's a really cool feature. But this is really helpful when you already know what specific session you want to go in and pay attention to. So one of the things I love about Wireshark is that it's just so easy to go through and kind of parse out the headers. I can go up and change what columns are actually getting listed up here. I can change the orders of them. I can, just by clicking on a field, I can see how that's actually being decoded out of the initial frame itself. So it's real easy to go through and do a very detailed analysis with this. I love the note stuff on the right-hand side. So like this info, also notice everything's in green. If there was like a TCP segment that went missing or something, it'll code it in red. So it's really good at showing me like network-based errors for doing troubleshooting purposes. And those stick out like a sore thumb. So for those types of things, I think, Wireshark is a really cool tool. The downside of Wireshark is it's kind of cumbersome. If I'm looking for specific patterns in a file that has, thousands or tens of thousands of systems talking to each other, oh, this is going to be really cumbersome to try to go through and do. Something like Zeek, which is summarizing everything out by connection pair status, might be a better way to go through and find that. So maybe I use Zeek to kind of target the specific connection pair I want, and then I can use Wireshark to go in and kind of do the deep analysis after that. The other problem you run into is Wireshark has to load the entire PCAP file into memory before it tries to process it. Well, if I've got 2 gigs of RAM and I'm trying to process a 20 gig PCAP file, the math doesn't quite work out, right? So what we end up with is using an awful lot of swap, which means everything starts kind of dragging and running slow. My other minor with Wireshark is because there's so much extra overhead due to the user interface. If you try to capture packets with it, you're far more likely to miss packets that are on the wire. In other words, as the packets are going by, the tool's trying to grab those packets. Well, if a buffer gets filled up, if it runs out of CPU availability, it's just going to ignore packets as they go by until it's able to recover those resources, which means you'll miss packets that go by. That tends to happen sometimes when you're creating PCAP files. There'll be stuff that's missing, and it'll be missing because the system wasn't capable of keeping up with it. Wireshark, because of all of its additional overhead because of the UI, tends to run into that problem more often than other tools. What are other tools? What are some other possibilities? Let me kick out of this. Actually, I can kind of put that in the background for now. Let's take a look at TCP dump. So TCP dump is been around forever. This is probably one of the tools that people initially cut their teeth on who've been at this for a while. Just because it's been available forever. It's available on every platform but Windows by default. And on Windows, there's a tool called WinDump that does the same thing, but it's command line based. Now, the fact that it's command line based tends to turn a lot of people off, but it's actually pretty easy to go through and use. So if I want to take a look at that Fiesta PCAP file, I can go in and I can say, hey, TCP dump, by default, TCP dump is going to try and resolve any IP addresses it sees to a fully qualified domain name. By saying -n, I'm saying don't do that, leave it as a raw IP address. It's also going to try and resolve any port numbers it sees to a well-known port name. I tell it don't do that, leave it as a raw port number. Just because, one, it's faster, and two is just because it went to port 80 doesn't mean it's HTTP. You got to actually look at the headers to kind of figure that out. But here's how TCP dump goes through and kind of processes that data. So you can see I've got summary information for every single packet that goes by. Now, there's some things that don't thrill me with TCP dump. One of which is the fact that all of my TCP flags are one-letter designations. So S for SYN, P for push, F for fin. The exception is the acknowledgement flag. They decided, oh, let's just call that a period. What? Why isn't that a capital A? Why is it for this one thing you chose not to follow that convention? I can't answer that question. I didn't write the code, but that's one thing that's always kind of bugged my OCD a little bit about this. One of the things I do love about TCP dump, though, is just how easy it is to go in and see payload information. So if I go in and I say dash capital X, and now I'm going to go through and I'm going to run this through the less command, so it'll give me a full screen worth of information and then pause. Once I do that, you can see, hey, I've got some header information here, and then I actually get to see a full decode of the payload. So I get to see the entire frame, or excuse me, the entire packet in hex, but I also get an ASCII translation of it. This stuff looks all messed up here. I talked about that last time because it's trying to use an ASCII table when the headers actually need to be converted to decimal, not ASCII. But that information is getting converted up here, so that makes it a little bit easier. But you can see here's all my payload information here, which makes it real easy to go through and follow. Now, if I want to decode more in those headers, one of the things I can do is I can go in and I can add a lowercase v. And when I do that, you can see, oh, hey, this gets a lot more descriptive about what it's saying, right? It's telling me, oh, hey, there's an HTTP header. Here's a breakout of the information that's there. I still get the full decode in there. And I can do 1V, I can do 2Vs, or I can do 3Vs, and that'll get about as verbose as it possibly can. So notice it even starts going in and showing me, checksum checks and what were the results of that and that type of thing. So good things about TCP dump. One is it's pretty much always there, right? If you're running a Linux system or a Mac, it's in the background, even if you didn't know it was there. If you're running like a Docker instance, they may not have chosen to install it, but most OSs will install it by default. I mentioned it's not available on Windows by default, but WinDump does it for you. One of the things I really love about TCP dump is it's very fast, very optimized. It's great for generating PCAP files. You're going to miss very few packets by creating your PCAP file, going in and using TCP dump. The downside about it is it doesn't decode all the fields, right? Like here's all of the decode information I'm getting using the 3V switches, but this isn't everything. What if I want to, see the raw sequence numbers? Well, there's actually a different switch I got to go in and I got to kind of pull out for that. There's also a couple of fields that it just doesn't bother to print out or give to you as an option to go through and print. So that's kind of a pain in the backside as well. I also can't pick the fields. By that I mean what you get is what you get, right? I can say VVV or VVV. I can't control it and say, no, no, no. I want to see the TTL, but I don't want to see the IP ID. Well, you can't do that with TCP dump. You just kind of get what you get, and you're kind of stuck with it for that. Now, one tool that will allow you to do stuff like that is T-Shark. So let's talk a little bit about T-Shark. So I'm going to go in and I'm going to look at that same file. So I'm going to say -n. So don't resolve IP. I don't have a don't resolve port option with T-Shark anymore. There used to be one. They took it away for whatever weird reason. And I'm going to go in and I'm going to say, read that Fiesta C2 PCAP file. And now I'm going to pump that through the less command. And here's how T-Shark decodes the information. Now, one of the things I kind of like about the T-Shark default is it kind of gives me a really good summary, and it uses less lines to do it. You may have noticed with TCP dump, there were always multiple lines getting printed for every single packet. Well, here it's actually able to fit a summary for each packet on the screen, which actually kind of makes this a little bit easier to go through and follow. Herman saying, I like T-Shark's decode way better, if I'm honest. Yeah, I agree. I think what keeps me using TCP dump is that's what I learned on. So it's familiar to me. So it's like All right, so I'm going to say it. VI and Vim are not the best text editors out there, right? When you compare features side by side, easy use, blah blah blah, Nano, some of the Emacs, those are probably easier to work with. But I cut my teeth on VI. That was the first text editor I was using in Linux. I know it by default. I can't tell you how many times I've been, editing a file with Nano, and then I go to quit and save and do a colon WQ. And then it just prints out a line that says colon WQ because that means nothing within Nano. But I keep using it because it's, familiar to me. So for some folks, it may just be, what falls into your comfort zone. That may be what you want to go with, and that's perfectly fine. One of the nice things is, hey, you always got options. But I agree. I think this, you know, decode method that they go through and use gives you some better information than what you get by default out of TCP dump. Now, what I don't like is if I say, hey, that's not enough information. I want to be a little bit more verbose, and I'm going to use a -v switch. Well, that's what, oh no, wait, that's giving me version information. Is it dash capital V? Or is it capital V? Yeah. This is the verbose information that you get out of T#. This is everything. So everything I'm scrolling through right now, that's just one packet. And oh wait, now we're into frame 2. So the verbose for T-Shark to me is just too verbose. They didn't even try. It would have been a nut. So like we saw with TCP dump, you could have 1V, 2V, or 3Vs. I'd love it if T-Shark, this was 3Vs, but I had a 1 and a 2V option that didn't take up 5 pages for every single packet that goes by. That would make life a little bit easier. But really it comes down to whatever makes your life easier. So one of the things that's really, now with that said, one of the things you can do with T-Shark that you can't do with TCP dump is you can specify the exact fields that you want to print out on the screen. Let me grab a command here. I'm going to throw this into Discord just so everybody has it available to them before I type it. I've been typing stuff out, but hey, there's only a couple switches here. It's easy for you to kind of see what's on my screen and just kind of follow along. What'd you do there? That wasn't right. Oh, I think I doubled the command. Yeah, no, this is right. Cool. Actually, let me change that command. Sorry, I got a lot on my screen. I want to make this a little bit easier to read. So I'm just going to change the command I gave you to be head just for a second, just so you can kind of see what's actually going on here. So I'm saying T-Shark -N, don't resolve any IPs to host names, -R, read this capture file, and see this switch here, -T fields. That's where I'm telling T-Shark, well, actually, technically, I should include the dash because you need that in the command. What I'm doing there is I'm telling T-Shark, don't print your default summary. I am going to tell you exactly what I want you to print on the screen. And what I want to see is, and I specify it using -E, and if I have multiple fields I want to specify, I need to use the -E over and over again, like you see here. But just to kind of run through what's here, I want to see the source address. I want to see the source port. I want to see the destination IP address. I want to see the destination port. And then this one kind of line wraps here. I want to see the URI of the data being requested. So it's not the URL, which would include the fully qualified domain name as well. The URI is just, hey, once you get to that server, this is the data in the directory that I want you to go after. Then I want you to print out the HTTP content type. So that is when the server says, hey, what I'm giving you is a text file, what I'm giving you is an application or an image file or whatever the case may be. We're going to take a look at that information if it's returned. And we also want to see the user agent string. So notice I'm being very specific about what I want, and I'm skipping a lot of the stuff that might be in the IP header or the TCP header and focusing heavily on what's going to end up being in the HTTP header. Now, when I run that, I get output kind of similar to this. So here it's saying, oh, this is probably our SYN packet. right? This is my source system coming from the source port, going to that destination IP destination port. So that's probably my SYN. The next one's going to be my SYN-ACK, and then this is going to be my ACK. So here's my TCP3 packet handshake. So the next thing we're going to see after that is what did the client send to the server? Well, it's only going to print out the fields that I have up here. So it's telling me, oh, hey, here's the URI, and here's the user agent string that it sent. Now, well, wait a minute, Chris, you had content type in there as well. Well, yeah, content type is something that goes from the server to the client. What we're currently analyzing is the client talking to the server. So that data isn't going to be here. It does show up down here, though. The server eventually responds back and says, oh, hey, that file you want, that's a text file, which is wrong. This is actually a C2 channel we're looking at here. But you get the idea. Now, if you want to kind of look through this more, instead of pumping it through the head command like I just did, because I wanted to be able to show you the command and the resulting output that was created by that, you can get rid of head and type in less instead. And then once you do that and hit enter, now you'll get a full screen worth of information. And you can see we have multiple connections taking place here. So we're seeing that multiple times. Now notice this. I have 10, 0 to 15 talking to 75, 75, 75, 75. And there's no ports and there's no source port and there's no destination port. What happened here? Let's go back to our command for a second. So our command was to print the TCP source port and the TCP destination port. Well, if I have two systems talking to each other via UDP or ICMP, there's not going to be any TCP ports to print out, is there? Now, one of the things I could do to avoid that is I could create a display filter that says, hey, only look at, TCP 80 traffic. And now those types of things would go away. But I wanted to do it this way just so you could see it. So you could kind of, if you ran into this in the wild, you'd kind of have a pretty good idea of what's going on. So this to me is kind of cool. The fact that I can go in and I can say, hey, only show me these particular things. This allows me to go through and check this stuff out. Now, you may say, well, wait a minute, Chris. We saw that in Wireshark, right? And with Wireshark, I could go in and I could say, follow TCP stream, and it would just kind of go through and do its thing after that. One of the cool things about doing this on the command line is I have the ability to go in and do some additional processing on that data. Let me show you what I mean by that. So I'm going to throw another command into Discord for you. There you go. And I'm going to go through and I'm going to paste that up here. And actually, let me kill it. I don't want to run it just yet. I want to read off what's actually going on here. So what's this command doing? tshark-n, don't resolve IP-r, read this pcap file, -t's. I want to specify the fields I want you to go through and print. I want to print the destination IP address, and I want to print the HTTP user agent string. This here is my filter that's saying I only want to look at HTTP traffic. So if it's UDP 53 because it's DNS, ignore it, don't care. If it doesn't have HTTP header information in it, regardless of what port it's going to, ignore it. I don't care. I'm only interested in traffic that looks like HTTP. Then what I'm doing is I'm sorting it. So what I'm saying is, hey, regardless of what order it was in the PCAP file, when the destination IP address and the user agent string is the same, list those out one line after the other. Then what I do, actually, let's do it this way. Let me show you that. And I'll just run that through head. So this is going through the PCAP file, and it's pulling up. So it found a bunch of entries where there wasn't actually an HTTP user agent string being used. So that's why these are showing up as blank. There are some in there if I do enough of it. Let's try -30 and see if that gives me something. I should at least see something in the first 30. No, of course I'm not, because it's a demo. Things never go right when you're doing a demo. Yeah, I'll come back into that in just a second. So I was sorting it. So again, anything that's blank will end up together, but anytime the user agent string matches, that'll end up together as well. And then I'm running it through unique. So what that's saying is, hey, if there is one line entry with a destination IP address in the user agent string, is there, just print that. If there's 15 line entries where the destination IP address in the user agent string is the same, truncate that down to a single line entry only. So what I'm looking at is I'm just saying, hey, I just want to see what user agent string was used with each target IP address. If it happened once or it happened 50 times, I don't care. List it only once. I'm interested in that unique combination that's taking place. Then what I'm doing is I'm removing some white space and I'm cutting out that destination user agent string. And then I'm sorting it, unique seeing it, and then sorting -rn on it. So what is this last part of it doing here? Well, what I'm saying is, okay, now that I can see every destination, what user agent string was used with each destination IP address, I don't really care about the destination IP address anymore because the problem I'm trying to solve here is I'm looking to see how often are certain user agent strings being used by this system based on the number of IPs it's talking to out on the internet. So I'm sorting it, and then see this here? That's what's counting it up. That's what's giving me this number that's over here on the left-hand side. So what does this mean? This means that our source system, when it was talking to 15 different IP addresses out on the internet, it used this user agent string, which identifies itself as being Windows 10. When it talked to 12 other IP addresses out on the internet, it used this user agent string instead, which identified itself as Windows 10. But there was one system it was talking to out on the internet that it was identifying itself this way, which I'm pretty sure that's Windows XP. So on Windows 10 most of the time, but when I talk to that one system, I'm going to turn into a Windows XP system. Yeah, it makes no sense at all. And then all those blank entries were associated with one particular system we were talking to out on the internet. So what does this do for me? When a attacker sets up a command and control server, they want to be able to stealth it as much as they can. So one of the things they'll do is they'll create like a secret keyword, right? Remember the old speakeasies? You went up, you knocked on the door, and if you didn't know the secret keyword, they wouldn't let you in to go drink. That's what this is, right? So when a system comes up and says, hi, I'm a Windows 10 system that wants to talk to you, the command and control server looks at that and says, oh, you're Windows 10? Here, I'm going to show you some default page. Oh, hi, I'm a Windows 11 system or I'm a Linux system. Oh, okay, I'm going to show you that same default page. Oh, hi, I'm a Windows XP system running Microsoft Internet Explorer 7 with a way out of date version of Java. That's the secret keyword. I'm going to let you talk to the actual command and control code now. So this is a very simple way for attackers to go through and make it harder for us, the good guys, to figure out what's going on in their servers. It's also kind of sticks out like a sore thumb, right? Most of the time we're Windows 10, but here we're not. So it's kind of easy to go in and spot this. But the fact that it's unique to this one system, how long would it take you in Wireshark to figure this out? I'm not even sure how I'd get started, right? Yeah, okay, there's some display filters I could go after to only show me the information that's there. But as far as like automating the counting process and all of that, I'm not sure Wireshark can actually do that. It could display this data and I could add them up manually, but I don't think I could see this? This could go in a shell script. And I could do this every day off of packets that are going by on my network. I could automate this entire process. This is not something I could go in and I could do at Wireshark instead. So you get the idea. So it's command line based, which, we like working with GUIs, but, come over to the dark side. We have better cookies and we have commands you can actually automate by going through and running it the command line instead. So this dash E capability to go through and identify what you want to display is a really powerful feature. How do I know what options are available? Well, you could go to the Wireshark website and do it, but there's actually an easy way. I can say tshark dash capital G. And that's going to show me all of the possible options that are available. Here's everything you can do with this. And actually, when it first pops up, it'll give me a line count, right? No. Yeah. Okay. It's not giving me a line count. There's a lot of lines here, as you can see. I'm just going to like page through a bunch of times and then it pauses. And, wait a minute, this doesn't look like IP, Chris. Yeah, no, it's not. The display filters are not limited to just IP. It works with a bunch of other protocols as well. Oh, wait, that's kind of hard to read. Let's clean that up a little bit. Let's say 40. There we go. That's a little bit easier to read, right? Now it's only one line per. So how much could possibly be there? Oh, you get the idea. There's a ton of stuff here. So you could do this and then scan through to try to find what you want to find. But there's actually an easier way. And I tell you what, I will share this command in Discord so that you don't have to worry about accidentally typing in something incorrectly. There you go. So that's the command I'm about to run here as well. So what is this doing? So I'm saying tshark-g, and as we just saw, that'll list out all of those display filters. And then what I'm saying is, okay, out of all of those display filters being listed, here's what I want to do. I want to use grep to go in and look for a space character, right? So it could be a space, it could be a tab. I want to see a blank space, and then I want to see the letters IP followed by a period. And if you see that, display it on the screen. Well, what does this do for me? Well, if I hit enter on that, notice these are all display filters just for the IP header and what's associated with the IP header, like geolocation information and stuff like that. You'd need an additional database loaded to get that to work properly, but you get the idea. My IP options are all here. Cool. Wow, that's a lot easier, right? Let's change IP to say TCP and see what happens. Oh, look, here's all my TCP filters. And if there's something that I know I want to go after, right? If I know that, let's say I want to, what's a good one? Yeah, let's say I want to specifically see my TCP options, right? I can type in backslash, and if you look at the lower left-hand side of my screen, you'll see it change to a backslash, and I can say option, OPTION, and then hit enter, and this will jump down and highlight all of the ones that have options set to it. So this allows me to very quickly go through this list without having to go out, find an external website, search through HTML pages, do it on the command line. It's a whole lot quicker. You don't want to do TCP. You want to do what? DNS? That one should work. Yep. Here's all my DNS fields that I could go through and display. So again, this allows me to go through and do this much, much quicker. It allows me to customize exactly what I want to extract out, and it puts it into a format that makes it real easy for me to go through and manipulate it. To go through and, as you saw me do earlier, hey, go through and count a bunch of stuff up and give me summary information. This can save you so much work off of trying to do this all manually. Makes life a whole lot easier. Now, these are all tools that are designed to just kind of go in and show you raw packet information, right? It's going to show us each individual packet that goes by. What if I'm not interested in every packet? What if I'm only interested in packets that may contain a certain piece of information? I'll give you a good example, right? So if you're using Reader or AC Hunter, that may pop up and tell you, hey, we think we've detected command and control over DNS. And you look at it and you say, oh, yeah, hey, those are definitely not names that a human would assign to a system, So, and they're not, no one's ever accessing any of these resources being queried. So, yeah, this looks like it's C2 over DNS. Well, if your Zeek sensor is running at your perimeter and you have DNS resolvers internally for your users to use, what AC Hunter is going to report is, hey, that source IP address, which is your resolver, looks like it's maintaining a command and control channel. And, that's accurate, but it's not the source. By that, I mean, it's probably not your resolver that got compromised. It's probably one of your clients. Your client just happens to be relaying its DNS queries through that specific resolver. So how do you go through and figure out which client was it? Well, you could turn on logging, but That always adds an awful lot of overhead. Or you can use this really cool tool, ngrep. So we just looked at grep a little bit earlier, right? We were using that to look for specific patterns in text. ngrep does the same thing with payloads, which to me is just so freaking cool. So I can go in and I can say, um, ngrep, I want you to search the payloads of packets to look for a particular character string. Let me show you what I mean. So one of the switches I always want to make sure I use is dash Q. If ngrep checks a packet, and actually, let me not use dash Q first. We'll add that. We'll come back and we'll add that one in later, and I'll show you why it's needed. So we're going to say dash capital I. I want to input a PCAP file. Well, wait, Chris, isn't that dash R for read? Yeah, it is for just pretty much just about every other tool except for ngrep. ngrep, the folks who programmed that decided, no, 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 we're going to use capital I for input and capital O to output and write a file. We're not going to use that dash R dash W that the commoners use. We're going to hoity-toity use capital I and capital O instead. Whatever. Hey, they wrote the code. We get to benefit from it. They want to make weird decisions like that. That's perfectly fine. All right. So I'm saying ngrep dash I, show me, I want to check the Fiesta PCAP file, and I need to give it a string to look for. I'm going to tell it I want to look for Google in there, just because I know that pattern happens to exist in there. And then I'm going to go through and I'm going to pump that through less so that I can see, one page at a time of data. And here we go. So what's this showing me? So it's telling me that the input file is Fiesta C2. It's telling me, okay, my filter is I can look at IP or IPv6, but the character string match to look for in the payloads is this string right here. And then it's saying pound, pound, pound. What does that mean? Anytime ngrep checks a packet to see if it has that character string in it, if it doesn't have one, it prints out a pound symbol. So it's ngrep's way of saying, hey, I checked that packet and didn't find what you looked for. I am actually doing something. I just didn't see what you told me to go out and look for. Well, the file we're looking at is mostly the traffic we're interested in capturing. There isn't too much superfluous other traffic in there. But on a live network with multiple systems communicating, you're going to get a lot of packets going by that don't have what you're looking for. So what you end up getting is pound, 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 pound. And then the string you were looking for zips by the top of the screen really quickly and goes away. And then it's pound, 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 pound again. You get the idea. The dash Q switch will get rid of these pound symbols. It's not really an issue here because we don't have too many of them, but you can want to use that dash Q for the most part. But notice what it grabbed here. So it said, hey, I saw a TCP packet coming from this source IP address, this source port, going to this destination IP address, this destination port. It had the ACK flag and the push flag turned on in the TCP header. This was the fourth packet inside of that capture. And here is that string you were looking for. So I'm going to print out the contents of the entire payload that included that string. So if we wanted to see, where does Google appear in any of the payloads going by, you can go through and do this. So funny story. So the ngrep's been around forever. I used to teach this tool back when I was teaching the perimeter security class for SANS. And one of the things that I decided, well, nobody would be doing this anymore. So it's okay to go through and do it. Is I went in and said, hey, so let me show you why we don't use clear text logins anymore. Because someone could use something like ngrep and say they want to match on login or pass. And if they do, and it's in clear text, that would grab any packet that went by with a login name and a password and clear text in there. But luckily, we don't do that anymore. And I hit enter, and it turned out, oh no, I had a number of students that were logging into POP3 mail servers using clear text and just happened to put their credentials up on the screen. Oh, I hate that when that happens. So you get the idea. You can potentially extract some scary information going through and doing this. But to go back to what I talked about before with C2 over DNS, where, hey, if we're monitoring at the perimeter, what we're going to see is the resolver. I could turn on logging on the resolver, but that might require a reboot of the process. That's going to, start taking up some additional disk space. It's going to slow the DNS process down. It might be easier to just load up ngrep and say, hey, ngrep, any UDP53 traffic that has, let's say the domain in question was, evil.ru, any packet that has evil.ru in it, go ahead and grab that for me. And when it does, it's going to show me the source IP address that's sending all those DNS queries. Boom, boom, bang. Within less than 2 minutes, I could easily go through and figure out who is the actual true source of what's going on. If the first hit in the cap is fourth packet, why are there 4 pound signs before it? Wouldn't it be the fifth? So I honestly don't know. The first one might be getting printed out just to show that it's actually printing pound signs. And then there's 3 after that that are showing up after that. Um, I get the feeling that whoever wrote this tool didn't do a lot with packet capture. Like there's a lot of conventions they just chose not to follow. And I think they didn't follow them because they didn't know about it. Dash Q, not printing those pound signs, should have been the default. There should have been a debug option that allows you to print those out, but they didn't choose to go through and do it this way. Chris, can you grab base 64 strings for non-encrypted connections? So yes, you can, but it has to exactly match. What we're doing here is a regular expression match. So what we're matching on is not the word Google. What we're actually matching on is the ASCII equivalent to that in binary, because that's what's going by on the screen. So if someone took the word Google and then base 64 encoded it, and then put that encoded message inside of the packet when they sent it, this would not match against that, because it's not going to go. And if you think about it, it makes sense. The overhead would kill it. If we took every packet that went by and said, well, maybe it's base 64, let me check that. Oh, maybe it's hex, let me check that. This would be a really slow running tool. So you've got to be able to go in and it's signature matching is probably a good way to look at it. It's got to go in and it's got to match on it exactly. But like I said, in a pinch, this can be a really good way to go through and kind of see what's actually going by on the wire. All righty then. So let's see if I missed anything. I think I pretty much remembered everything I gave you. Follow TCP stream. We talked about that. Strengths and weaknesses of Wireshark. We definitely talked about that. TCP dump. I showed you that. We talked about the dash capital X, the good and bad with it. T-Shark, we talked about that. Oh, here's a pretty screen that puts TCP dump up here, T-Shark down here, so you can visually easily see the difference between the two. And, I think a couple of us said, yeah, we kind of prefer the T-Shark output. Hey, personal preference. Whatever works for you, that's what's to go for. There's no right answer. Well, there's no wrong answer. It's right if it works for you. I gave you that command to go through and do. So we talked about that. I talked about what I love about it. I talked about the fact that one of the cool things about doing this at the command line is that I can do additional processing against this as well. I can also put it in a bash script. So all this stuff here, right? I could write a bash script that's called unique U, right? Just because I'm not a creative person. Unique UA. There you go. So I could write a bash script named unique UA that has all of this in it, right? Everything here, except where it has the PCAP file name, put in a $1. And now I can go to any PCAP file and say unique UA, and then the name of the PCAP file, and it'll process that PCAP file exactly this way for me. So I don't even have to type all this stuff in. So again, we're kind of getting into automation and stuff like that. Yeah, you can automate an awful lot of this that's going on. I talked about this. Okay, so I was trying to give you a total of how many display filters there are. Look at that, 204,000. There's a lot. You won't ever need 204,000. You probably stick with the IP-based ones for the most part. And I talked about how to go through and look for that. So the good strengths and weaknesses of T-Shark, we talked about that, talked about ngrep. Oh, I didn't talk about this one. If you want to do, right, so when we did that search for the word Google, that was case sensitive. If we want to make it case insensitive, we'd have to add in a lowercase I as one of our switches. Here's some other examples. So here I'm just watching an SSH session so you can see, hey, here's how the client identified itself. Or excuse me, here's how the server identified itself. Here's how the client identified itself. So if you want to watch handshakes going back and forth like that, SSH is encrypted channel, but most encrypted channels start off in plain text. So there's usually some amount of information you can go through and enumerate in the clear. We looked at this one, we went through and did that. And so many tools, so little time. Yeah. So if I didn't cover a tool that you really love, like Zeek or whatever, please feel free to go through and share that in the Discord channel with everybody else. This is not designed to be like a complete coverage of all the tools you might ever want to use. We don't have enough time for that. But I did want to hit some of the common ones, and I wanted to hit some of the features and ways to use it that a lot of times, if you just kind of pick the tool up and start using it yourself, you may not even know that feature is available to you. So like I said, go through and share that. So Eric and I were talking the other day, and I think we were trying to figure out which one of us is older. But one of the things we figured out was both of us are old enough that this was the first packet sniffing tool we both used. And I would love to see if there's anybody on Discord that's, let's say, younger than 50 that actually knows what tool that might be. If you think you know, go ahead and throw it in the Discord channel. BetterCap. Nope, it's not BetterCap. Ethereal. Oh, that's a good guess. So Ethereal is the predecessor to Wireshark, but no, it's older than that. Let's see, older but more immature. Yep, definitely that. So um, this is the interface for the Network General Sniffer. So go back to the early 90s. There was another tool that showed up between this and Ethereal, which was LAN Manager. That was another tool you could use to go in and kind of grab packets with. But this predates them all. So when you bought a Network General Sniffer, what you bought was you bought software that you could run on your, 50-pound compact portable computer. It was definitely not portable by today's standards, but it was considered portable back then. And what they also sold you was a network card, because the network cards at the time weren't capable of running in promiscuous mode and being able to grab packets. And they also used it as part of their license keys and the whole bit. But look at this interface. It's not that different from what we were looking at in Wireshark, but it's certainly not as good as what we had in Wireshark either by a long shot. So yeah, this is where we went through and started. So NetScout Sniffer Pro is another. Oh, I never used that one. So that's cool. So yeah. If you know about if you're as old as me and you know of one that's even older than the Network General Sniffer, please go ahead and share it. But this is the first one that I'm aware of, and it's the first one I ever used. And I think that was like late 80s, early 90s, somewhere in that time frame there. I don't know. It all runs together at that time. Keith and I were talking earlier. At that point, I was following the Grateful Dead around. So the fact that I have any brain cells left at all is like just a huge surprise. So next week on Fireside Fridays, I will not be here. I've got jury duty next week, which, I might get selected, I might not. It depends on how things go. I'm going to wear my Princess Leia outfit, and maybe they'll pick me, maybe not. But rather than take a chance on whether I can be here or not, the illustrious Bill Stearns has agreed to step in and run a class next week. Bill's going to be talking about IPv6 for IPv4 users, which should be pretty cool. Bill's official job title at Active Countermeasures is Master of Shitty Little Shell Scripts. Yep, he does actually have that on business cards. So you're in good hands. You are definitely in good hands with the IPv6 stuff next week. So with that said, I'm going to go back on video, and Keith and Fawn, if you guys are still around, you're welcome to come back in too. We got about 4 minutes left. If anybody's got anything else they want to be able to toss in.
Yeah, I'm still always around.
You never go anywhere, dude. You're
Yeah.
you're you're always working. So
Yeah, I'm like a bad virus.
yeah. Oh, I do want to add in one more thing. So Bill will be talking about IPv6 for IPv4 users next week. The week after that, I will be back and I'll be talking about packet crafting. So this week we talked about how to look at packets. In 2 weeks, I'll talk about how to actually create any packets you want to and kick those out on the wire. So that should be a fun one too.
Yeah, and I'm also looking forward to next week's for IPv6 because admittedly I'm one that's been resisting IPv6. And I, and I think
Yeah,
it's
it's
about
definitely
time.
one. Yeah, it's definitely one of those. If you don't have to use it, you try to get away with not having to use it.
Yeah,
So,
yeah, yeah. I mean, my primary beef is it's difficult to look at and remember,
mm.
but other than that, I mean, there's nothing actually wrong with it. So I think it's about time I give up my resistance and just go with it. So
So it's kind of funny. I was chatting with a buddy that I used to work with a couple of years ago, and he reminded me that I set a goal in my life to be out of this industry by the time IPv6 became mainstream, just because of the number of issues with it. And, yeah, Keith, is the stuff that you're talking about. But, one of the things that I ran through. So now, to be fair, this is going back 20 years. Hopefully, it's not the same anymore. But I started doing things. So IPv6 does a lot of weird stuff that Bill will talk you through. But one of the things they changed is, with IPv4, the header can change in size if you have options set. With IPv6, the IP header is fixed in size, and you can have multiple headers that show up before you get to the TCP or UDP header. And what I found was that you can get devices to do some really strange things by messing with what order those headers show up in. They expect them in a certain order, and if you change that, sometimes you get unexpected results. And I just remember going through doing that testing on IPv6 and thinking, oh my God, it's ping of death all over again. Meaning like back in the early 90s, we ran into a lot of really basic buffer overflows and, lack of data scrubbing issues with IP. And over time, we've kind of worked them out for the most part. I mean, yeah, some of them come back a little bit on occasion, teardrop, teardrop. But, for the most part, IPv4 is fairly clean. In IPv6, it was like all that crap came back again. And maybe it's been cleaned up by now, but that's always been like my biggest concern. So it's not just the size that scares me, Keith. It's the security.
yeah, yeah. Well, I totally agree. And especially as threat hunters. I mean, and I think Fon's latest blog post where he's talking about IPv6 rotation and
Yep.
how a single host can use multiple addresses. Uh, being a threat hunter, if you're not well versed in IPv6, I mean, you can miss a lot of stuff happening. So
Yeah, absolutely. Absolutely. So luckily we got Bill to come in and make us smarter on that. So that'll be
yes,
cool.
absolutely.
So for the folks saying thank you to you folks as well. As I said, these are not free. These webcasts are not free. You have taken an hour plus of your day and chose to spend it on us versus doing something that might actually be more constructive in your life. And we do appreciate that. We do appreciate the fact that folks turn out. But with that said, Keith, I'm done. You done?
I'm done. Yeah, this is great. Again, thank you, Chris, and thank you everyone for attending. And the engagement on Discord is always awesome. So we appreciate that
Yeah.
as well. Appreciate the questions, the answers, the conversation, and it all makes us better. So thank you.
And next week will be my week to not be here and be talked negatively about and get lots of action items. So
Yes. Yeah. In fact, I've already started a list for next week.
perfect. Perfect, man. Awesome. All right. Take care, everybody. Thanks for joining.